students. Now today we are discussing the tricks to write down electronic configuration of the elements. So when you consider electronic configuration of the element, first we discuss what is meant by electronic configuration of elements. So electronic configuration of the elements is nothing but the arrangement of the electron, the arrangement of electrons around the nucleus, in various cells. Arrangement of the electrons around the nucleus in the various cells. So we know that when you consider the structure of the atom, in the structure of atom, in the center there is a nucleus. This is a nucleus. Now nucleus contain proton and neutron. So this is a nucleus which contain proton and neutron. Okay. Around the nucleus, the number of the various energy levels are there, and these energy levels are also called as cells. So we know that if you consider this energy level, it is denoted as a K, L, M and N. When N is equal to 1, it is a K cell. When N is equal to 2, it is a L cell. When N is equal to 3, it is the M cell. And when N is equal to 4, it is called as N. So N is equal to 1, K, 2, L, then M, then N, like this way. So as we go away from the nucleus, the energy levels or the energy of the cells will be goes on increasing, and therefore the K, L, M, N, these are the various cells. It observed that for every cell there is a subcell. So let us consider. So when I consider N is equal to 1, the main cell, which is also called as a energy level, which is a K cell. When N is equal to 2, L, N is equal to 3, M, N is equal to 4, it is the N. For every main cell, there is a subcell. For every main cell, there is a subcell. The subcells are, the first main cell has a one subcell. The second subcell has a two. The second cell, has a two subcell. The third main cell has a 3 subcell, and the fourth main cell has a 4 subcell. So how you consider the subcell? So as it is N is 1, so it is the first energy level. It has a subcell, and these subcells are S, P, D and F. The subcells which are present are S, P, D, F, where S is a spherical in the shape, P is a double in the shape, D has a double dumbbell shape, and F has a complicated shape. So these are the SPD here, they are called as a subcells. They have the various type of the cell. It observed that these subcell SPDF we can consider for the main cell are like this way. For the first main cell, there are one subcell, and that one subcell you can consider in the SPDF like this way. So it is a first S. For the second, there are the two subcell, and they are the first two, that is a 2S and 2P. For the third main cell, the subcell are SPD. So these are the 3S, 3P and 3D. And for the fourth, the subcells are 4S, 4P, 4D and 4F. So like this way, these are the subcells for each main cell. It observed that these subcells has a orbital. S has a one orbital. S has a one orbital. P has a 3 orbital. D has a 5 and F has a 7 orbitals. So they have the orbitals. It observed that S has only one orbital, like this way. P has a 3 orbital. D has a 5 orbital. And F has a 7. I draw here. F has a 7 orbital, like this way. So these are the orbital. F has a 7 orbital. I can draw this orbital. So like this way, these are the 7 orbitals for the F subshell. Okay. So as S has only one orbital, so there are the maximum 2 electron in the S orbital. P has a 3 orbital, so they are called as Px, Py and Pz. The P subshell has a spherical, it has a dumbbell shape. Okay, S has a spherical shape. The S will be symmetrical in the all direction. So it is a like this. So X, Y, Z, if you consider it is symmetrical in all directions. It has only one orbital. But P has a orientation in the 3 direction, such as a Px, and then Py. If it is oriented in the Y direction, it is a Py, and it is oriented in the Z direction, it is a Pz. So depending upon which type of the in which direction it has an orientation, it is a 3 type: Px, Py and Pz. Similarly, the D has a 5 orbital. D can be considered, there are the orientation of the D is a 5. So these are the dxy, dxz, dyz, or dx square minus y square and dz square. So these are the 5 orientation of the D orbital by considering x, y, z direction. dxy means this orientation, the orbital, it has a dumbbell shape. So this is a x and this is a y direction. Then their orbital are in between x and y. They are in between x and y. Similarly, dxz means their orbitals are in between x and z. dyz, they are in between y and z. dx minus y square means they are along the x and y direction, and dz square means they are along the z direction. So remember, they are in between xy or xz or yz. I can draw like this way. So if it is a xz direction, they are in between x and z. If this is a yz direction, if this direction is yz, they are in between y and z. If I consider dx square minus y square, means they are along the x and they are along the y. They are along the x direction and they are along the y direction. And if I say it is a dz square, means they are along the z direction. So like this way, I consider the orbital. D has a 5 orbital. So I will repeat, S is a symmetrical in the shape. Okay, so it has only one orbital, but P has a 3 orbitals. So they are Px, Py and Pz. D has a 5 orbitals: dxy, dxz, dyz, dx square minus y square or dz square. So like this way, these are the 5. Now F has a 7 orbital, but the shape of the F is complicated, so we are not considering, or we are not possible to draw on the paper. Okay, so like this way, SPDF has a orbitals. Okay, now each orbital has a maximum of the 2 electron. Each orbital has a maximum of the 2 electron. So as S has only one orbital, so it has a maximum of the 2 electron. P has a 3 orbitals, so therefore each orbital has a 2 electron. One is in upward direction, another is in downward direction. So therefore there are the total 6 electrons in the p orbital. Now D has a 5 orbitals. So there are the 10 electron. Each has a 2 electrons. So 5 has a 10 electron in the d orbital, and F has a 7 orbital, and each contain the 2 electron. Therefore 7 has a 14 electrons. Maximum capacity of the F orbital is the 14. Okay, look here, I will repeat. So when I consider KLMN as a main cell, each main cell has a subcell. These subcells are denoted by SPDF. So one main cell has one subcell, so it is 1S. Two main cell has a 2 subcell, 2S and 2P. 3 main cell has a 3 subcell, 3S and 3P, 3D. 4 main cell has a 4 subcell, 4S, 4P, 4D and 4M. Like this way, these are the 4 subcell. It observed that for every orbital, for every subcell has a orbital. S has only 1 orbital, but P has a 3 orbital, D has a 5 orbital, and F has a 7 orbital. As each orbital has a maximum capacity of 2 electron. So why orbital has a maximum capacity of the 2 electron, it will consider later on. So but if each orbital has a maximum of the 2 electron, so as one orbital has a 2 electron, so therefore S has a maximum capacity to accommodate electron are only 2. P has a 3 orbital, so it has a 6. D has a 5 orbital, so it has a capacity of the 10 electrons, and F has a 7 orbital, so it has a capacity to fill up the electrons are the 14. So like this way we can consider the filling of the electrons. Okay. So before we consider the electronic configuration, we must know the capacity of the electron to be filled up in the corresponding subcells and the orbital. So now it observed that as S has a only 2 electron possible here. So when I consider, now we know that we can find out the maximum number of electrons. So maximum number of electrons in the each main cell. You can find out maximum number of the electron in each main cell. So maximum number of the electron in main cell. You can find out now. So they can find out by formula 2n square. It also find out by the formula 2n square. Okay. So in the first cell, the value of 2 into n is a 1 square, that is it is a only 1, and therefore 2 into 1 is a 2. For the second, 2 into 2 square, so 2 into 4, that is the 8. For the third, 2 into 3 square, 2 into 9, that is the 18. For the fourth cell, 2 into 4 square, 2 into 16, that is a 32. So the first main cell has a maximum capacity of 2 electrons. It has 8 electrons, 18 electrons, 32 electrons, and then 15 electrons. Like this way you can consider. Now you can check how these electrons are 2. Now look here, we know that S has a maximum capacity of the 2 electrons. So here the number of electrons are 2. Now S has a maximum capacity of the 2 electron and P has a 6. So it is a 8. S has a maximum capacity of the 2. P has a 6. D has a 10. So it is a 18. Here S has a 2. P has a 6. D has a 10. And F has a 14. So this is now, it is again your 32. So this is a 18 plus 14. So it is a 32. So like this way you can check the maximum number of the electron in each main cell. So before to draw the electronic configuration of the element, we must have the knowledge that how much electron is found to be present in each main cell, each subcell, and what is the capacity of the electron for orbital. So now today we are discussing the 3 main points. The main cell has a subcell, and subcell has a orbitals, and these orbitals are SPDF. So like this way. So this SPDF or subshell are SPDF, and their orbitals are either px, py, pz, or dxz, or dxy, or dyz, or dx square minus y square, or dz square. So like this way you can consider the orbital for the D, and F has a 7 orbital. So like this way we can consider the orbitals also. Okay. So now let us consider how to write now electronic configuration of the elements. Okay. So in order to write the electronic configuration of the element, we can consider that S, P, D and F. S has a maximum capacity of 2, it has a, P has a 6, D has a 10 and F has a 14 electrons. Okay. So in order to write the electronic configuration of the any element, I give the simple trick that you remember that like this way. Suppose So in order to write the electronic configuration of the elements, we have to know the sequence of the orbital in which the electrons is to be added. So when consider the electronic configuration of the element, we have to add the electron according to your above principle. Now above principle say that the filling of the electron will be takes place in increasing order of their energy. In increasing order of energy. According to above principle, we have to fill up the electron in the orbital 1s, 2s, 2p, 3p like this way according to their increasing order of their energies. Means those orbital having lower energy will be filled up first. Those orbital will be having the higher energy will be filled up later. So how we remember that? We know that one has a 1s orbital, 2 has a 2s and 2p orbital, 3s has a 3p, 3s, 3p and 3d orbital, 4s has a 4s, 4p, 4d and 4f orbital. So how we can fill up this electron in this orbital? So for which every time we have to consider the energy. So therefore I give the sequence that will be gives a direct idea that to fill up the electron in orbital in subshells like this way. So look here. So when I consider the filling of the electron in that subshell, so we must know that maximum capacity of the electrons. Second thing is that the S will be started from 1, the P is always started from 2, D is always started from 3 and F is always started from 4. Remember. So when I consider the sequence in which the corresponding electron is filled up in the subshell. So SPDF are the subshell. So we consider the sequence in which the electrons are found to be present in the corresponding subshell. So for this I give the simple trick that so 1s, so I can first write down like this way. So SS, so remember it is a school, then public school, Delhi public school, then F for Farooq, Delhi public school, Delhi public school. If you remember like this way, it is easy to remember or to write the electronic configuration. So after 1s there is a 2s, then 3s. I can first write down all s. So 1s, 2s, 3s, 4s, then 5s, 6s, 7s and 8s. Then P from 2, 2p, 3p, 4p, 5p, 6p and 7p. from 3D, 4D, 5D, 6D. Okay. Then F is from 4F, then 5F. So if I consider the one by one, 1s, 2s, 2p, 3s, 3p, 4s, if you go like this way, ultimately according to your above principle, the electrons are added in increasing order of their all these subsets. Okay, so like this way. Suppose I have to write so for this we have to remember only simple word: school, school, public school, public school, Delhi public school, Delhi public school, Farooq Delhi public school, Farooq Delhi public school. Or you can write like this way: school, 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 public school, public school, Delhi public school, Delhi public school, Farooq Delhi public school, Farooq Delhi public school. So like this way you can remember. Now suppose that I have to give one element which suppose the atomic number is 19. I have to write down electronic configuration. So how you fill up the electronic configuration? So first write down 1s. We know that S has maximum capacity of the 2 electrons. So 1s. Then 2s. 2s also has a maximum capacity of the 2 electrons. Then after 1s, 2s, then we go for 2p. P has a maximum capacity of the 6. Then 3s. S has a maximum capacity of the 2. Now we count the total number of the electrons. So 2, 2, 2. So these are the 10 and this is 12. So we again have to proceed. P has a maximum capacity of the 6. Okay. So 10 and 8, 18. Now we require 1. So after the 3p we go for 4, and now there are the 18 electrons already finished. 10 plus 8. So only 1 is remaining, and that is 4 as well. So this is the electronic configuration of the element whose atomic number is at 19. Suppose I consider the element having the atomic number as at 33. Okay. So we go like this way. So 1s2, 2s2, 2p6, 3s2, 3p6. Okay. Then after 1s2, 2s2, 2p6, 3s2, 3p6. Then I have to go for 4s2, then 3d10. Okay. So now count. So 10, 20, this is 30. Okay. So then next is a 4p. Next is a 4p. So how many are remaining? 10, 20, 30. So these are the only 3. So it has electronic configuration like this way. Suppose I consider element is Z is suppose a 26. Z is a 26. Okay. So go proceed. 1s2, 2s2, 2p6,